The most familiar form of electromagnetic radiation is, however, there are many other forms of electromagnetic radiation. As we mentioned earlier, we have X-ray, UV light, radio wave, microwave, and also the infrared. And this one we have covered in the previous. Okay, for electromagnetic spectrum, as we can see, the gamma rays, it have highest energy, but it contains shorter wavelength with higher frequency. And the most longer wavelength is radio wave because they have lower frequency and lower energy. Okay, we can see that this is the types of radiation. For example, radio wave. We use the radio wave in transmitted by radio broadcast, TV broadcast, and even cell phone. For microwave, in the broadcast information through space as well as warm food. For infrared, released as heat or thermal energy, most commonly used in remote sensing, as infrared sensor collect thermal energy, providing us with weather condition. And also the gamma rays we use to chemotherapy. We use the light for chemotherapy for tumor cancers patients. Okay, this one is the electromagnetic spectrum again. So short wavelength will produce high energy radiation, for example, in gamma rays and X-rays. And for long wavelength will produce low energy radiation, for example, in the radio wave. And this one on the right is the long wavelength with low energy radiation, and the one in the left is the short wavelength with high energy radiation. Visible light. So visible light contains the narrow band of frequencies and wavelength in the portion of the electromagnetic spectrum that our eye can detect. So it includes radiation with wavelength between about 400 nanometer, which is violet, and 700 nanometer, which is red. Because it is a wave, light is bent when it enters a glass prism. So when white light is focused on a prism, the light rays of different wavelengths are bent by differing amounts and the light is transformed into a spectrum of colors. So starting from the side of the spectrum where the light is bent by the smallest angle, the color are red, orange, yellow, green, blue, and violet. And the types of color, it will have a different wavelength. As we can see in this figure, the red color most highest wavelength compared to the other. Okay, UV radiation is most commonly known because of its severe effect on the skin from the sun, leading to cancer. X-rays are used to produce medical image of the body, and the gamma rays can use in chemotherapy in order to get rid of tumor in a body since it has such a high energy level. That's why gamma rays is very dangerous to us, and for cancer treatment will lead to many disadvantages of the patient itself. Okay, light can interact with matter in three ways, as we see in the previous slide, which is absorption, transmission, and reflection. So visible light exists in wave with distance frequency, which is wavelength, specific to a corresponding color. So for different material, it will absorb different wavelength and it will notify through the color at at which it will display on the screen. And the electron in an atom, which is responsible for interaction with light, will vibrate at specific frequency to call as a natural frequency. So please be aware the words vibrate. Thus, it is the contact between the frequency of the light wave with the frequency of the electron vibration that determine whether light is absorbed, reflected, or transmitted. For absorption, a light wave with an identical frequency is introduced, And the electron will absorb the light wave because it has the same vibrational frequency. And the light wave is turned into a vibrational motion. And the vibrational is changed into a thermal energy. And this thermal energy is not turned back into the light energy. Thus, the particle light wave never leaves the object again. And this is called as a absorption. And this one is the mechanism of absorption process in light. For reflection, this occurs when the frequency of the incoming light wave does not match that of the electron natural frequency, and the electron vibrate briefly before emitting the wave back out as light. So we call it as the reflection. For transmission, it works along the same lines as reflection, except it involves transparent or semi-transparent object. And the atom takes in the wave, which is vibrate briefly but at a small amplitude, not like during absorption where when they vibrate with large amplitude. So it transfers the vibration through the body of the material and then re-emit the wave as light out of the other end. So we call it as a transmission. So this is the mechanism of transmission. Okay. Advantages of spectroscopy. It is much rapid and less time consuming, valuable in analysis of highly complex mixture, requires small amount of compound, precise and reliable. And that's all for this chapter. Thank you.